Good morning, students. So, in the last class, we have discussed about the uh, gas welding and precautions to be taken and the types of oxyacetylene flames. So, in the last class, we have finished these chapters. And today's lecture, we are going to discussing about the application of different gas flames, combination of gases, and gas welding techniques, that is left or forward welding, rightward or backward welding, vertical welding, welding practice and safety. Combination of gases. Apart from acetylene, other gases also can be combined with oxygen to develop different flame. In oxyacetylene gas welding, we are using oxygen and acetylene. Apart from the acetylene, other gases also can be combined with oxygen to develop different flame temperatures. So observe here, gas flame, oxyhydrogen, its temperature is 2400 to 2700 degrees centigrade, and it is used for the application of brazing. This is underwater gas cutting of steel. These are the types of welding processes. And oxy coal gas, temperature 1800 to 2200 degrees centigrade, right? And it is used in silver soldering. Next, oxy liquid fuel, 2700 to 2800 degrees centigrade. To 2800 underwater gas fitting welding. Next, air acetylene, 1825 to 1875 degrees centigrade, that is brazing and soldering. So these are the combination of gases producing the flames apart from the oxyacetylene, oxyhydrogen, oxy coal gas, oxy liquid fuel, air acetylene. And next, gas welding techniques. So depend upon the following factors, that is material being welded, the material, the properties, okay, if it is ferrous or non-ferrous material. So based on that, we are going to do techniques, welding, following welding techniques. And the thickness of the workpiece, based on the thickness of the workpiece also different types of gas welding techniques are there. And shape and size of the workpiece, shape and size of the workpiece, properties anticipated of the joint. So we are the some of the properties required while going for the operation, while after the operation. So the properties anticipated of the joint. So based on these factors, we are going to deal some of the techniques, that is leftward or forward welding technique, rightward or backward welding, vertical welding. In this, leftward or forward welding, in the simplest way, the welding can be taking from right hand to left hand. That is, the welding process is moving from right hand side. This is right side, and it is moving this side while doing the welding operation. It is a leftward or forward welding. If the welding is started at left hand position and it is moving to the right side, that is a right hand or welding. So in the diagram you can observe, and this leftward or forward welding is used for the thickness of the material is 5 mm. If the 5 mm thickness of the materials using doing the gas welding, where we go for the leftward or forward welding. That is how the operation is done. In this, the filler rod is filler material. Filler rod is nothing but filler material is in the left hand at an angle of 30 to 40 degrees. This one, and it is a welding torch at the right hand, in our right hand, and it is an angle of 60 to 70 degrees. Okay, and the welding process commences at the right hand side of the joint and proceeds to the left. So it starts here, the sectioning part showing the uh, starting position here, the welding going from here to here, started at the right side and going to the leftward. So these are the edge preparations that will come in the next class. Next slides. So welding commences at the right hand side of the joint and proceeds to the left. So this technique assures a more uniform weld, and its cost is less with the thickness less than 5 mm. And this is useful for the less skilled operator. And a right word. In this also, this method is used for the over 5 mm thickness plate. So technique is explained in the diagram. That is, the welding, the filler rod is in the left position and the welding torch in the right position in the angles, and the process is commences from left to right. It starts at the left end and moves to the right end. So better penetration of weld can be attained. In this method, filler rod is held in the left hand at an angle of 30 to 40 degrees. Rightward or backward welding. So the torch is in the right angle. Welding action starts at the left hand side and proceeds to the right hand side. With this, we can get the improved mechanical properties. Next, the last method is vertical welding. So vertical welding, two plates are positioned in vertical position and the welding starts at down position. Welding starts at down position and the welding can be done at on both sides. So it in the this side one operator can done the welding process, and another side also the one of the other operator can do the welding process, and the welding process commences from the lower end downwards to upwards. So welding is commenced at the bottom and proceeds vertically upwards. Generally, two welders are employed for vertical welding on either side of the joint. So this side one operator can do and another side one operator can be done the operation. So while doing this operation, if the one operator is employed, the angle of the torch varies with the plate thickness. So there may be errors, material properties may be changed. So in vertical welding, there is no requirement of edge preparation. That edge preparation will become in our next classes. So because of less edge preparation, less amount of filler material can be used. And it is advantageous for plates more than 6 mm thick. Okay, these are the welding methods: leftward or forward technique, rightward technique, and vertical welding operations. Based on the thickness of the material, we are going to these three welding techniques. If the thickness of the plate is below 5 mm, we go for the leftward technique, and if the thickness of the plate is above 5 mm, we go for the right hand technique, right? And vertical welding over 6 mm, we go for the vertical welding. And welding practice and safety. So first, edges are to be prepared and position is maintained with fixtures. And first of all, acetylene gas is to be released and ignited, and correct flame is adjusted. And the torch is held at an angle of 45 degrees and filler rod at 30 to 40 degrees to the workpiece. The filler rod is to be moved uniformly in the joint in both speed and feed, and the surfaces has to be cleaned by wire brushes. Safety measures: goggles, face shields, gloves, and protective clothing is to be used properly. Hoses should be connected properly. Oxygen and cylinders have different threading to avoid mistake. Right hand threads and left hand threads. Gas cylinders should not be dropped and mishandled. These are the safety measures. And next we are going to discussing about the edge preparation for gas welding, advantages and disadvantages of gas welding, and applications of gas welding technique. So first we have to start with the edge preparations. To obtain sound welds, good edge preparation is essential, involves in suitable relieving the edges and careful cleaning. The edge of the workpiece must be clean and free of dust, oil, or grease. So, edge preparations for many types of joints, chamfers are needed. If we are doing chamfering operation on the edges of the two workpieces, that should be called as a edge preparation. So, why the edge preparation need? Because to obtain sound welds, good edge preparation is essential. Different edge preparations is particularly used in fusion welding process for welding butt joints. Butt joints are square, single V, double V, single U and double U. So ఈ welded joints అన్ని మీరు మెషిన్ డ్రాయింగ్ లో చూస్తారు. So the preparation of edges depends upon the thickness of metal being welded. Square butt weld may be used for thickness of from 3 to 5 mm. Before welding, the edges are spaced about 3 mm apart. So in the diagram, you are observing the edge preparations. So first of all, the materials are like this. After doing edge preparation, so chamfering cut, we are getting this type of edge. So the preparation of edges depends upon the thickness of the welded. So square butt weld, this is one of the edge preparation, square butt weld, and it is used for the thickness from 3 to 5 mm. And before welding, the edges are spaced about 3 mm apart. The distance between the two edges should be 3 mm. And the single V butt welds are frequently used for metal over 8 mm and up to about 16 mm thickness. The edges forming the joint are believed to form an included angle of 70 to 90 degrees depending upon the welding technique to be used. Double V butt weld are used on metal of 16 mm thick where welding can be performed on both sides of the weld. So double V butt weld. These are the all edge preparations. Square butt weld, single V butt weld and double V butt weld. Single and double U butt welds are used on metal 20 mm thickness. So all these edge preparations, all these types of edge preparations depends upon the thickness of the materials. If the metals over 20 mm thick, we are going to for the method single and double V butt welds. If it is 16 mm thick, it is double V butt welds are used. So in the diagram, you can observe the butt joints, edge preparations, different types of edge preparations. So before edge preparation, the material, the arc will go up to here only. For edge preparation, it fill complete gap. So edge preparation, up to 1 mm thick filler rod dia 1 mm, 1 to 3 mm 1.62. This is for leftward technique and this is outward technique. Edge preparations are like this: square butt weld, square V butt weld, double V butt weld. This is double V butt weld, single V butt weld, square butt weld. Okay, based on the thickness. And coming to the advantages of gas welding, the cost and maintenance of gas welding equipment is low compared to the arc welding. And equipment is versatile and used for preheating, brazing and is readily converted to oxygen cutting. High portability and convenient. Oxyacetylene flame is more easily controlled and can be used for all metals and alloys. Welding skills are relatively easy. Welder has control over filler metal deposition. And the disadvantages: takes longer time to weld as gas flame takes a long time to heat the metal. Heat affected zone and distortions are longer. The refractory and reactive metals cannot be gas welded. Oxygen and acetylene gases are expensive. Shielding provided by flame is not affected. Heavy sections cannot be welded. More safety problems are associated with handling and storage of gases. And the applications: oxy-acetylene gas welding is a versatile process and can be used for welding all commercial metals and alloys. Due to low temperature of gas flames, the process is employed for welding thin sections. The process is mostly used in sheet metal fabrication workshop, aircraft industries, garages, maintenance shops. These are the applications, advantages and the disadvantages of gas welding. Thank you.